Okay. Number 19, find the equivalent resistance and the current out of the battery for a series circuit with 3 resistors. Also prove Kirchhoff's voltage law by showing the sum of the voltages around the loop is 0. Do the math for this. Okay. For an actual solve-it problem, you're likely to see either series or parallel, but not necessarily a combined. You are likely to see a combined where I just asked you to describe something, or I ask you to find like one value given some numbers. So it's not to say you won't see a combined parallel series circuit, but if, like, for a bigger problem, you're likely to see one or the other just as a standalone, just because otherwise those multiple ones just take a long time. I'm trying not to make any of the problems take you like 10 minutes to solve this one problem on the final. So here's my battery, 5 volts. Here's my resistors. Okay, so you got 2 ohms, 5 ohms, 10 ohms. All right, wants to find the equivalent resistance and the equivalent current, and then it wants you to use Kirchhoff's voltage law. Okay, so first of all, I don't know why I just don't keep this out here. Here's the series circuit. You just add them all up. So the equivalent resistance when they're all in series, 2 plus 5 plus 10 equals 17. Okay, so there's the equivalent resistance, easy enough. Then it wants you to find the current. The equivalent current is Ohm's law, so V equals IR, but it's V equals IR for the whole thing. So I would say V for the whole thing would be 5 volts. Yeah, let's just use the numbers. 5 volts is the voltage for the whole thing. I for the whole thing is what we're solving for. And R for the whole thing is what we just found. So you divide that to both sides. And you get I equals 0.29 amps.
Mr. B, are we going to have any of those ones where you have to like solve for like, I don't remember what they were called, but you had to solve like a whole bunch of different things?
No, since it's multiple choice, like you may have to, like on this, like obviously we're doing lots of things. You may have to do any number of those or multiple of them, but they would be separate questions. Yeah. Okay, so we found the first thing, we found the equivalent resistance, we found the equivalent current. Okay, now we need to find Kirchhoff's voltage law. So here's Kirchhoff's voltage law. Voltage law is this one. So the total voltage is equal to all the little voltages added up. So I just wanted you to prove that that works. On the final, you would be more likely to see a problem where I like give you 1 or 2 of the numbers and you got to find something else. I'm just having you work through multiple of them just so you get some practice with it. So the voltage law says this. The total voltage 5 equals the little voltages added up. So we'll call this V2 plus V5 plus V10. Well, how do I find those individual values? Well, I just do V equals IR. So V2 equals I. Remember, in series, everything has the same current because they're all connected together. So V equals I R. So that's 0.59. Okay, V5. V equals I R. $1.47. And V10. V equals I R. And that would be 2.94. So we add those up and see what we get. So 0.59 plus 1.47 plus 2.94 gives me 5. Now, on the final, you're more likely to see a question that says, like, here is the voltage and current for these resistors. What's the total resistance? Or here's the total, or for what's the total voltage? Or here's the total voltage, find the missing voltage. Like, that's more likely what you're going to see for this. This would be, here's a combination of resistors, find the total value. So it's not going to be one problem that does all of them, but you should be able to do all three of these. You should be able to do V equals IR. You should be able to combine voltages together in a loop. You should be able to solve for series circuit.